Hello everyone, I'm Bipul Talukdar from SiFive. So I am from the verification team over there, and I have been doing formal verification and some amount of simulation using Chisel. It's been around a year that I have started learning Chisel, and it was an interesting journey. So, so I will share a bit of it today in this session. So how many here are familiar with formal verification in general? Like I'm talking about formal property verification. So we have got some hands there, so that's great. So I have a backgrounder slide here. So in formal verification, we encode design behaviors with some properties. And we make sure that those properties are not violated under legal stimulus. And the legal stimulus could be any piece of work in hardware, like an RTL, or it could be some properties applied as constraints. And the biggest advantage in formal verification is that you can hit corner case bugs that not hit in simulation. The problem in formal verification in general is a state space issue, and that is the reason why block level formal verification comes in the sweet spot of things. And that is one of the reasons why whenever we did formal verification at SiFive, we started with block level formal verification. And with that, we could get the benefits of block level verification at the same time formal verification because we did not have to encounter state space issues. We use different industry standard formal verification tools from different vendors, but in this specific case, I use Jasper Gold from Cadence. So you'll have some snapshot of that here. The primary goal of this, the motivation was increasing the verification productivity. So as I already mentioned that block level formal verification is something geared for productivity improvement at SiFive. We have a very dynamic hardware verification flow. You change something in our configuration, you have new RTL. You get a new piece of RTL. So the test in a dynamic hardware development flow has to be dynamic in nature too. So we make sure that whenever we write tests, those are generatable as well as per the requirement of the parameters in different configurations. So that's guaranteed by our use of diplomacy and our, in general, the methodology that we follow at SiFive. So the takeaway, so I put the takeaway slide in front because I want to make sure that after going through these slides, few slides I have, you have a methodology in mind how to apply formal verification using Chisel. And if you do not have that sense of idea at the end of it, come to me, talk to me, write an email, we'll make sure that you have a methodology in place for formal verification using Chisel. So it's very simple in reality. So all you do is write your Chisel code as per your test, and then you follow the general flow of generating your RTL. And once you have an RTL and a file list, that file list is subject to an industry standard formal verification tool, and you have all your properties popped up in that tool, and you pretty much try to get proof from those properties. And I have a success story here where I started with a few small blocks. Like I have got a tile link to APB bridge. That was the DUT I selected for this work. And there I have a slave interface of the tile link protocol on the left side of the DUT. That's the DUT. And on the right side, I have a master interface of APB protocol. And to verify this in formal, I required one tile link master driver, and I needed one APB slave responder on the other side. And I could subject this setup to a formal verification tool. And my goal was to prove all the properties. And whenever doing that, I call these drivers and responders as virtual tile link master and virtual APB slave responder. So here's a typo in this slide. The second bullet should be virtual APB slave responder. Why these are called virtual? It's because whenever subjected to formal verification, the properties itself behave like a driver and a responder when those properties are applied as constraints. So that's what I mean by here, formal targets and constraints. All right, so with that in mind, I had to basically write a formal verification IP. And what I mean by that is the master driver and a slave driver, for example. These are my two different formal verification IPs for APB and tile link, for example. And how I did that is I wanted to ensure reusability. What I did is I created one class for tile link protocol in general. And in that class, I implemented logic for tile link protocol. And for APB, I did a similar thing. Then I used that class to create my drivers and responders. And the interesting thing here is that So basically in this slide, I saw on the left side my property logic class. So in my property logic class, I create a fire signal. And that fire signal basically encodes the behavior of a property that I want to prove. And that signal per property is available. So basically, if I have n number of properties for a specific protocol, I'll have n number of fire signals, and I will write Chisel code to encode the behavior of the protocol on those specific fire signals, and then I make those fire signals available in the implementing master driver and slave responders. So that's on the right side of it. So you don't have to go in the detail of it because the slides are available, so you can have a look. And I saw the connections, how this happens. I first create a property logic class on the left side, and I use that class on the right side to create my master driver and slave responders. And I have the fire signal connections happening under the IO connections in that specific driver and responder implementation. And then how I create my property. It's over here. So I use a property object. So in that, I have like an apply method which can take in parameters like the property can be generated as a assertion or can be generated as assumption, that I mean constraint, or it can be generated as a cover. Now, what is the advantage I'm getting out of it doing like this? The advantage here, the way you want to generate this property is pretty flexible. So in system Verilog methodology in general, you do not have that flexibility. You can write various apply methods in this property object to generate your properties as you please. For example, if you want to do like say cross coverages, you can do that. You can just write an apply method. Or if you want to do, say, you want to generate property with zip with index or something, you want to like 100 number of properties you want to generate depending on how large is your signal vector is. So all that you can do in this specific in a class. I haven't shown that example, but there is one example I have shown here. If you look, I have a cover property here. If that cover is not met, then I am generating that as an assert. So you have got that kind of flexibility whenever you are doing things like this. Now, once you have your verification drivers and the verification responders, so those are basically, we call them platform components for verifications. Once you have your platform components for verification ready, then it's time to write the test. And writing the test is the easiest that you can, the easiest thing in Chisel, I would think, once you have your platform components ready. It's as simple as just bringing in your, first you define what are the parameters you want for each of your drivers and responders, and then you just create your drivers and responders, and then after you just do your diplomacy connections, which looks so simple, but under that, a lot of magic happening, like all the signals are connecting precisely how it should. So that's why your test is so concise, so readable. So that's what I like the most about writing a test in Chisel. It's great. And in System Verilog, I have to do the same thing. It will be like a lot of connections, and the readability is completely gone. So that's great. And this is my FPV run snapshot. So whenever I generated my properties, generated my drivers, responders, and I have got a file list, I subject that to the formal tool. And once I did that, then I have all my properties coming up, constraints, everything coming in. This is a Jasper Gold snapshot. That's the tool from Cadence. And apparently, one thing if you notice here that the property names are kind of clumsy. It's because right now we do not have something in place which will make the properties, with some intuitive naming. So these are right now just so the file name and the line numbers with column numbers, and that's how we could. That's how I did it basically. So anything failed to debug, I had to go back and find the line number and column number. I did not have an idea like which property actually failed. So that is something probably we can work on at some point. And another thing I have noticed, given this generated code, somehow it's optimized to a good limit, and I could find, in my experience at least, that these proofs that I was getting was somewhat faster in general than I was writing a manual code. I'm not sure why that exactly happened. I did not time it, but that was the sense of it I was getting. I was able to get like 100% proof for all the properties. This was around, I think, around 108 properties that I could get, and there are some properties falling in there in the red over there, and those are apparently properties not relevant to the functionality of the block. So that's why I mentioned that I got 100% proofs and for all the important properties. So these are some of the steps that I referred here and some of the gotchas. Regarding the gotchas for debuggability, I would like to add that I could use suggest name successfully, and that was my lifesaver to debug things whenever debugging a property. And the other things was I had to use black boxing for keeping signal alive. I just learned that I could use maybe do not touch. But that did not work for me in the first place, but I will go back and retry and see what's happened. If it doesn't work, I'll report it, just in case. That's pretty much done, and if you have a question.
Okay, let's thank the speaker. We'll have a little time for questions. I also want to ask the next speaker, Richard, to get ready. I have one question, which is, does your system also support temporal properties like LTL properties?
So these properties that we generate is kind of pretty simple because either like yes or no kind of properties. But for doing that property, you have to encode it in your Chisel and then create logic accordingly. So there is no library in place as such.
Okay. Does anyone else have a question? Anyone else has struggled with formal verification of Chisel-generated designs? Apparently everyone is happy. So I have another question. How easy do your properties, like you have some properties for a tiling bus, right?
Right.
How easy do you think would it be to apply them to a completely different independent implementation of a tiling peripheral or tiling?
Well, so as long as your implementation has similar properties across the interfaces, so these are like black box properties, so it should be okay to be able to use them.
All right. Thank you very much.